Hi everyone, we are from Group B, which consists of 5 members. First is me, Amira Iliani binti Effendi. The second member is Chi Zhe King. The third member is Lisa Lim Shi Min. The fourth member is Maisarah binti Halimi. And last but not least is Nur Shafika binti Mihai. This is the instruction that we get to start our discussion for biochemical oxygen demand. BOD is the amount of dissolved oxygen needed by aerobic biological organism to break down organic material present in a given water sample at a certain temperature over a specific time period. Appendix 1 shows the data for BOD, DOC, and SFS for 4 locations of water resources. We need to generate 50 data from random number, and this is 50 data that been filtered by my group mate. Hi, I will explain about graph and table between biochemical oxygen demand, BOD, and location. So from this table, it shows a different value of average of BOD for 4 different locations. For location 1, the value average of BOD is 1.54 mg per L. For location 2, average of BOD is 1.50 mg per L. For location 3, 1.61 mg per L. And last but not least, location 4, 1.50 mg per L. From this graph, it shows the relationship between average of BOD versus location. We can conclude that the location 4 and 3 has lowest value of average of BOD, which is 1.50 mg per L, while location 3 has highest value of average of BOD, which is 1.61 mg per L.
Hi, my name is Maisarah binti Halimi. So I will explain about graph and table between dissolved organic carbon, DOC, and location. So from this table, it shows a different value of average of DOC for 4 different locations. For location 1, the value is 1.87 mg per L. For location 2, the value is 1.94 mg per L. For location 3, the value is 1.83, and lastly, for location 4, the value is 1.73 mg per L. From this graph, it shows the relationship between average of DOC versus location. We can conclude that location 4 has lowest average of DOC, which is 1.73 mg per L. Meanwhile, location 2 has highest value of average of DOC, which is 1.94 mg per L. Next, I will explain about table and graph between synchronous fluorescence spectra, SFS, and location. So from this table, we can see the value for average of SFS for different locations. For location 1, the value is 345. For location 2, the value is 343. For location 3, the value is 332. And lastly, for location 4, the value is 338. So we can see the graph is show the relationship between average of SFS and location. We can conclude that location 3 has lowest value of average of SFS, which is 332. Meanwhile, location 1 has highest value of average of SFS, which is 345.
Yes, so hi, my name is Nur Shafika. So I'll present question B2. So the question asks to test at 5 significant level if there is a difference on the OC reading between location of water sources, and write the ANOVA model and its assumption. So here is the data contained of 4 locations, so meaning that we have 4 population, and therefore we need to use ANOVA because of the population is more than 2. So for the hypothesis, H null is mu1 equal to mu3 equal to, H null is mu1 equal to mu2 equal to mu3 equal to mu4, while H alternative is mu I is not equal to mu j for at least one ij. So before I'm moving on this ANOVA table, let me go through this table first. As you can see, the value of n1 equal to 10, n2 equal to 10, and so on is actually the value of data contained in each column, while y1 dot, y2 dot, y3 dot, y4 dot is the submission of data in each column. For example, y1 dot, as you can see, this arrow shows the submission, the addition of all the datas. That's why you got y1 dot. So the total data contained in this table is n equal to 50. You need to understand all these value, how to calculate all the value, because when it comes to calculating the data manually, it's very important. I'm not used to calculate manually because I'm use Excel to calculate my ANOVA table. So moving on my ANOVA table, so there are source of variation between groups, within groups, and total. So just put your value here for sum square, and for degree of freedom, for total, which is n minus 1, n is 50, 50 minus 1 is 49. So the degree of freedom for treatment is k minus 1, k is 4, come from 4 location. So 4 minus 1 is 3. And degree of freedom for error is 46. So for the mean square formula is, for treatment is sum square treatment divided by k minus 1, degree of freedom treatment. So you got this value 0.157294. So same as mean square error. Okay, so this is what we need, is the value of f test, which is 1.327975. This value it comes from this formula, mean square treatment divided by mean square error. Okay, so step is to reject H now if f test is greater than f alpha. So f alpha is 0.05, and degree of freedom treatment is 3, and the degree of freedom of error is 46. So from the table I got 2.806845. So for the f-test, got from ANOVA table, we got 1.327975, which is less than 2.806845. Therefore, fail to reject H null. Fail to reject H null because there is no significant difference in the OC reading between the location of water sources.
Hi, my name is Qi. So in this question, we need to apply the simple linear regression analysis, follow the data by fitting a linear regression that relates to biochemical oxygen demand (BOD) and synchronized fluorescence spectra (SFS). So based on the 50 data that filtered from my group mates, I only use the data of biochemical oxygen demand (BOD) and synchronized fluorescence spectra (SFS) only. I use computer applications such as SL to get the answer for this question. First question needs us to find the linear regression model. So this is the equation for linear regression model. So what is the value for alpha and beta? Based on this summary output, we knew that intercept coefficient means alpha, while S variable coefficient means beta. So after we substitute the value to the equation, we knew that a unit increase in biochemical oxygen demand (BOD), the synchronized fluorescence spectra (SFS) lead to a 0.000774773 unit decrease. For this question, we need to test the linearity between the biochemical oxygen demand (BOD) and synchronized fluorescence spectra (SFS) at 1% significant level. Comment on the value of R for the fitted linear model. This is the value for R. This is the value for F test, and value for significant S, value for T test, and this is the value for P value. First step, we need to list down H0 and H1. H0 means there is no relationship, while H1 means there exist a linear relationship. We have 4 ways to make our decision. First, reject H0 if F test is greater than F alpha n minus 1 k minus 1. Second, reject H naught if F test is greater than P alpha over through V. Third, reject H naught if significant F is lesser and equal to alpha. Fourth, reject H naught if P value is lesser and equal to alpha. So, based on the table, we know that alpha is equal to 0.01 and significant F value is equal to 0.526144971, which is equal to P value also. So, hence, we fail to reject H naught. So, there is no linear relationship between biochemical oxygen demand (BOD) and synchronous fluorescence spectra (SFS) in this question. So, based on the table, we know that R is equal to 0.07012999289, which is close to 0. So, what is the meaning? It means that implies little or no relationship between biochemical oxygen demand (BOD) and synchronous fluorescence spectra (SFS).
Finally, we need to test whether the BOD data from the 50s data do contribute the normal distribution with mean 1.5 and variance 0.135. Thus, we need to use the goodness of fit test. This is the table we conclude from the 50s data whereby we use the range of 0.2. This is the hypothesis test. Null hypothesis is the data is follow the distribution of normal distribution with mean 1.5 and variance 0.135, which is the claim of the calculation. The alternative hypothesis is the data is not follow the distribution. Next is the calculation. We need to calculate the probability by using the formula of z-test, then finding the expectation value to put in this formula. Finally, the summation of these values is equal to chi-square test, which is 12.4257. For the decision rule, we will reject H0 if the chi-square test is larger than the chi-square alpha. Due to the question, it does not mention the significance level. Therefore, we list out all the significance level from 0.5 to 10%. From table 3, chi-square test is bigger than chi-square alpha 3 at significance level of 10%, 5%, 2.5%, and 1%. The data reject H0 at those significance level. However, chi-square test is smaller than the chi-square alpha of significance level 0.5%. H0 is failed to reject at significance level of 0.5%. The data is follow the distribution of mean is 1.5 and variance is 0.135 at significance level of 0.5%.
That's all from our group. Thank you.